This one is as simple as -8. 10 raised to the power -2 is 1/100, which is 0.01 times 8. It's going to be 0.08 plus 100. It still has minus, okay? So it's going to be 100 minus 0.08. What will be the value? Minus 0.08. You are going to have 99.92. That's the value. But we are looking for length. The unit, if you look at the question here, is in meter. 99.92 meter. 99.92 meter. And that's the value for final length. Question number 3. A bimetallic strip of iron and brass was heated. Which of the diagram accurately illustrates the shape of the strip after heating? We have two different materials here. We have brass, we have iron. And we are told that by the time we apply heat, some quantity of heat on the material, there is going to be an expansion. And if we apply the same quantity of heat on different material, for example, we have brass, we have iron, the rate at which each of them will expand will be different because of their level of expansivity. Okay? We have brass, we have iron. Okay? The question says by the time we suspend the two material, the two substances to heat, the question says which of the diagram we have above will accurately illustrate the shape of the strip after it has been heated. Will it be this one? No. Will it be this one? Yes. Will it be this one? No. Why? Because the expansivity level of brass is more greater than that of iron. Okay? That is why the brass is curved outward. Okay? While the iron is curved inward. Okay? Because the expansivity and ability of brass is more higher than that of iron. And thus, the right answer is option B. Question number 4. The question says the length of a side of metallic cube at 20 degrees Celsius is 5.0 centimeter. Given that the linear expansivity of the metal is 4.0 times 10 raised to the power -5 per Kelvin, find the volume of the cube at 120 degrees Celsius. This is a cube which has a length, it has a breadth, it has a height. Because before we can have cube, automatically we are talking about the volume of this shape. And the volume is length times breadth times height. Automatically, this question is cubical expansivity because we are considering 3 dimensions: length, breadth, height. Okay? The length of that cube is 5 centimeters. We are given one side, 5 centimeters. And once one side is given, automatically the other side has been given. Because cube have the same length of side. Okay? Length is equal to breadth is equal to height for cube. It's the combination of square that gives us cube. You have, this is a square, it has the same number of sides, another square gives us cube. So they all the sides are what? Equal. So now, once we are given one side, automatically we can get the following: 5 times 5 times 5, which is 125 centimeter cube. 125 centimeter cube. 5 times 5 is 25. 25 times 5 is 125. And this value now, that is the original volume. Don't take 5 centimeter in the question as the original volume. This is not the original volume, which is 125 centimeter cube. We have to calculate the final volume. Let's make from cubical expansivity. So cubical expansivity is equal to change in volume, original volume, change in what? Temperature. We need final volume. Okay? From there we can say change in volume is equal to, we are first multiply original volume, change in temperature. But do you know that change in volume is final volume minus original what? Volume, which is equal to the whole of this again. This times this. This is V naught, change in temperature. So this is also V naught, change in temperature. So now, final volume will be equal to the whole of this, plus V naught, which is equal to, something is common here. Let's factorize. This one is common, bring it out. Then we have change in temperature plus 1. And that is the expression we are going to use to calculate the final what? Volume. Let's now look at the question and substitutes. Final volume will now be equal to original volume 125 into, in this case, we are not given the value of cubical expansivity, but we are only given the value of linear expansivity. So we are still going to multiply instead of having cubical expansivity. And you remember I said this is equal to 3 alpha. So we are going to have 3 alpha plus 1. So I'm still going to have 125 into 3 times. Then let's look at the value of linear we are given, which is 4.0 times 10 raised to the power minus 5 per Kelvin. 4 times 10 minus 5, that's that alone, times change in temperature. Our temperature change is from 20 degrees Celsius to 120, which is going to be 120 minus 20 in brackets plus 1 plus 1. This is what we are going to do now. This is 125 into 3 times 4 will give us 12 minus 5, then times 120 minus 20, that is 100, everything plus 1, which is equal to 125 into, okay, we are going to multiply 12 by 100. Let's see what is going to be the value. 1200 times 10 minus 5 plus 1. Let's move this. 1, 2, 3. We are going to have final volume to be equal to 125 into. So once we move this one 3 times, 1, 2, 3, we are going to have 1.2 times 10 raised to the power minus 3. 1.2 times 10 raised to the power minus 3 plus 1. Okay? And what will be the value of this? 125 into, this is 1.2 times 10 raised to the power minus 3 is 0.001 plus 1. From this alone is 0.001, which is equal to 125 into 1.2 times 0.00. What will be the value of that? 1.2 times 0.001 will give us 0.0012. 0.0012 plus 1. Okay? Let's follow it the way it was to. So 0.0012 plus 1, what will be the value? Plus 1 will be equal to 1.0012. You are now going to multiply everything by 125. By 125. By 125, it will now be equal to 125.15. But we are looking for final volume, centimeter cube. 125.15 centimeter cube. Let's consider question number 5. The question says 2 metals, P and Q, are heated to the same temperature difference. If the ratio of the linear expansivity of P to Q is 2:3 and the ratio of their lengths is 3:4 respectively, the ratio of the increase in length of P